Welcome, math lovers. In today's video, we are going to talk about relationship between nCr and nPr, also linear relationship and circular arrangements. So in nCr, we spoke about the number of ways you can choose R things out of n, but it doesn't talk about the order. For example, we have three things A, B, and C, and we want to choose two out of them. So it's like 3C2 here. So that could mean AB can be chosen, AC can be chosen, BC can be chosen. Only three ways here. So 3C2's value by your nCr formula. As we all know, nCr formula is given by n factorial by r factorial into n minus r factorial. So if we expand through that, you'll understand you'll get this 3. 3 factorial by 2 factorial into 3 minus 2. What is 1 factorial? So the answer will come 3. So this is the three ways. But the same three ways in nPr, meaning the order also matters. So this AB can be written, BA can be taken up. AC also CA. BC also CB. So this makes it 6. This makes it 6 ways. So that's why our NPR formula is given by n factorial by n minus r factorial. Since NPR is following the ordering idea, there'll be more ways of doing it compared to nCr. Look at the relationship and the definition. So when I multiply our nCr formula by r factorial times, I'll get nPr. So that is the relationship. nCr formula multiplied by r factorial times is going to give us nPr. So next we'll discuss about the linear relationship. So linear meaning if suppose 5 people are going to be seated in like say 4 chairs. 5 people are there, but only 4 chairs are there. So here if I'm going to talk about only choosing those 4 people, it'll be 5C4. For 5 people, you have to choose 4 people for those 4 chairs. But now if the ordering like who sits first, who sits second, who sits third, who sits fourth, if that also matters, then it's going to be like into 4 factorial times because 4 ways for the first person to take his seat, 3 ways for the second person, 2 ways for the third person, and 1 way for the last person, so which is same as 5PR, 5P4. Clear? So this is the uh, arrangement idea in linear arrangements. So now let's talk about this ABC thing. So if ABC has 3 people, if they are going to be arranged, you can see ABC, ACB, BCA, BAC, CAB, CBA. So it makes it totally 6 possible arrangements. So the reason for that is very simple because for the first seat to be occupied, there are 3 ways to do that because it can be either occupied by A or B or C. Now the second seat to be occupied, there will be 2 possible ways, so 2 ways. The last seat will be occupied only 1 possible way. So this is happening kind of simultaneously. So 3 into 2 into 1 creates us 6 ways. Okay. But if I have to make these people A, B, C stand along a circle, let's see what happens. Because in circle, there's nothing like first place, second place, third place and all. So A, B, C. Now like count this way. So A, B, C. So the first arrangement is there. A, C. Okay. So the same A, B, C. You can see A, B, C started from A. If I do it clockwise, I got A, B, C. If I start from B, it's like B, C, A. If I start from C, it is C, A, B. So all these three arrangements are this inside this single diagram. If I take the other arrangement, like say write it ACB, now see what happens. So clockwise ACB, and then clockwise CBA, and clockwise BAC. So these three other arrangements are coming in this single diagram. So uh, in linear, whichever was 6 arrangements, in circular, it is only 2 arrangements. So for circular arrangements, we use the formula n minus 1 factorial. For linear, we use n factorial for distinct people. Okay, for circular, we use n minus 1 factorial. And the next consideration here is if the clockwise or anti-clockwise doesn't matter. It would not matter if you are looking at identical objects or something. Okay, so then our answer is n minus 1 factorial divided by 2. If clockwise or anti-clockwise does not matter, then we'll have n minus 1 factorial divided by 2. So that will be our answer. Okay, so hope you got a good introduction on linear arrangements, circular arrangement, and the difference between combinations and permutations. So we'll meet you with more interesting questions on this. Thank you.